Okay, it says here, describe the solubility of CaF2 in each solution compared to its solubility. Okay, let me just click this link and download this file here so I can get a better understanding of what we're looking at. Okay. So what question is this? 1, 2, 3, 4, 5, 6 here. So I want the CaF2 solubility compared to solubility in water. So they're all the same concentrations here, so that's fine. In NaCl solution, NaF solution, and this HCl solution. Okay, so care about the solubility. And what we want to know here is we actually want to write out our chemical reaction here. So let's write that out. So I have, for number 1, I'm going to have CaF2 plus NaCl. And it's going to react to form NaF plus CaCl2. And we can balance this, obviously. So it's 2. And this here is a balanced chemical equation. So that's number 1. Number 2, I would have CaF2 plus NaF. In this case, even if you do a double splice reaction, it's the same common ions here. So this solution here doesn't like not react, but in this case, if you do a double splice reaction, you get the same thing back. So in this case here, there's no really reaction here. And 3, I have CaF2 plus HCl. It's going to give me CaCl 2 plus HF. We can balance that as well. So what we can do here is, so we can look at the solubility here, and it really depends on kind of which kind of ions it's actually soluble in. And we all have calcium here in this case, and we have sodium, and we have these halogens here. So it says here the effect on solubility in given solution with respect to that in pure water. So it says here the solubility in solution is the same as pure water. In the presence of solubility of calcium fluoride decreases as compared to in pure water because of the common ion effect here. So this is the common ion effect. We have Ca here and Na here. We have F here and F here, and these guys too. Both of these guys have a common ion of fluorine here. So these guys would not. It would basically decrease the solubility for 2. So this case, 2 would be a decreased solubility, which is great. So this is a decreased solubility because of the common ion of fluorine. NaCl is probably NaCl is a neutral solution, so basically it would be the same solubility as if it were to be in water. So because of this reaction, and then we know that chlorine here is soluble, right? Chlorine here is soluble, except for only these 3 guys. So these 2 guys are going to be soluble in water. So this here, it does not affect so that I can write it's no effect here. And then finally in acid here, this is HCl here. This is going to increase our solubility, right? Because again, the CaF2 is going to react with our HCl, going to give us calcium chloride and hydrogen fluoride here. So in this case here, the acid here will be good. It will be very, very soluble in water, because it's going to increase in an acidic solution. So this one would be increased here. And as you can see here, it says the solubility of insoluble salts increases in the presence of strong acid than in pure water. So this here is so solubility of calcium fluoride increases in an acidic solution. So solution here is correct. Good analysis.